Abstract, this article examines the organizational implications of behavioral homogeneity in large language models, LLMs, a phenomenon we term the artificial hive mind. Drawing on a comprehensive analysis of 26,000 real world user queries and 70 plus language models, we reveal that contemporary AI systems exhibit pronounced intramodal repetition and intermodal convergence, generating strikingly similar outputs despite variations in architecture, training, and scale. From an organizational leadership and work design perspective, this convergence poses critical challenges. The erosion of creative diversity in AI assisted workflows, the potential amplification of groupthink in decision making processes, and misalignment between organizational needs for pluralistic solutions and AI capabilities. We introduce evidence based organizational responses spanning leadership communication strategies, work redesign initiatives, and governance frameworks. Our findings demonstrate that current reward models and AI evaluation systems are miscalibrated to human preferences when responses exhibit comparable quality but divergent styles, a critical gap for organizations deploying AI at scale. This research provides practitioners with actionable frameworks for diagnosing AI homogenization in their workflows, redesigning roles to preserve human creativity, and building governance structures that promote cognitive diversity rather than algorithmic conformity. Organizations worldwide are rapidly integrating large language models into knowledge work, creative processes, and strategic decision making. From content generation to ideation sessions, from customer service to strategic planning, AI systems have become embedded collaborators in how work gets done. Yet a troubling pattern is emerging beneath the surface of this technological transformation. The outputs these systems generate are becoming increasingly homogeneous, both within individual models and, more critically, across different AI platforms. This homogenization represents more than a technical limitation. It poses fundamental challenges to how organizations design work, develop talent, and maintain competitive advantage through diversity of thought. When employees across industries rely on AI systems that converge on similar ideas, metaphors, and problem framings, organizations risk losing the cognitive diversity that drives innovation, adaptability, and resilience. The stakes are particularly high because this convergence operates invisibly. Unlike previous automation waves, where capabilities and limitations were readily apparent, AI's linguistic fluency masks its tendency toward uniformity. Employees may believe they're accessing a broad spectrum of possibilities, when, in reality, they're encountering variations on remarkably similar themes. A manager seeking creative metaphors for organizational change might unknowingly receive the same river of transformation imagery from multiple AI assistants. A strategy team brainstorming market entry approaches may find different AI tools proposing conceptually identical frameworks with only surface level linguistic variation. This article examines the artificial hive mind phenomenon through the lens of organizational leadership and work design. We analyze how AI homogenization manifests in real world work contexts, assess its implications for organizational performance and employee development, and provide evidence based frameworks for organizational responses. Our research reveals that this challenge extends beyond generation to evaluation. Current AI based assessment systems struggle to recognize that multiple diverse responses can possess comparable quality, a critical blind spot for organizations implementing AI assisted performance management, quality assurance, or decision support systems. The organizational context, understanding AI integration in modern work, defining the artificial hive mind in workplace settings. The artificial hive mind manifests across two organizational dimensions. Intramodal repetition occurs when a single AI system consistently generates similar outputs to comparable prompts, limiting the diversity of ideas available to individual users. An employee repeatedly consulting the same AI assistant for creative input receives variations on identical themes rather than genuinely divergent possibilities. Intermodal homogeneity, the more organizationally consequential dimension, emerges when different AI systems independently converge on similar outputs, even when employees deliberately seek diverse perspectives by consulting multiple platforms. This convergence operates at both surface and semantic levels. Surface-level homogeneity appears as verbatim phrase overlap, where different models generate identical or near-identical text segments. Semantic homogeneity manifests as conceptual convergence, where models propose fundamentally similar ideas expressed through different wording. Both forms undermine organizational goals of leveraging AI to expand rather than constrain the solution space. The workplace implications differ markedly from academic concerns about model capabilities. Organizations care less about theoretical diversity potential than about practical cognitive range in operational contexts. Can AI assisted brainstorming sessions genuinely expand thinking? Do multiple AI consultations provide meaningfully different strategic options? Can distributed teams using different AI tools generate complementary rather than redundant insights? State of AI adoption in knowledge work. AI integration has accelerated dramatically across organizational functions. Content intensive roles, marketing, communications, customer service, legal research, increasingly rely on AI for drafting, editing, and ideation. Strategic functions employ AI for competitive analysis, scenario planning, and market research. Creative teams use AI for concept development, copywriting, and design ideation. Technical roles leverage AI for code generation, documentation, and problem solving. This ubiquity creates network effects in homogenization. When employees across functions, departments, and even organizations use similar or identically trained AI systems, convergence compounds. Marketing teams across industries generate similar campaign concepts. Strategy consultants propose analogous frameworks. Product developers arrive at comparable feature ideas. The result, reduced differentiation not just within organizations, but across competitive landscapes. Several drivers accelerate this convergence. Centralized deployment models mean entire organizations often standardize on single AI platforms, eliminating diversity at the source. Common training data across providers, particularly for open source models, creates shared biases and framings. Alignment techniques that optimize for human preference ratings inadvertently optimize for consensus rather than diversity, training models to generate safe outputs that offend no one but inspire few. Cascade effects emerge when AI generated content enters training corpora for subsequent models, creating feedback loops that reinforce dominant patterns. Organizational and individual consequences of the artificial hive mind. Organizational performance impacts. The artificial hive mind threatens multiple dimensions of organizational performance. Innovation and competitive differentiation. Organizations achieve competitive advantage partly through distinctive thinking, novel problem framings, unique strategic approaches, differentiated positioning. AI homogenization erodes this differentiation by funneling diverse organizations towards similar ideas. Research on innovation emphasizes the importance of recombinant novelty, Fleming, 2001, combining existing elements in new configurations. When AI systems consistently suggest the same combinations, organizations lose access to the adjacent possible, Kaufman, 1995, that drives breakthrough innovation. Decision quality and strategic optionality. Effective strategic decision making requires comparing genuinely different alternatives, each with distinct risk reward profiles, implementation requirements, and competitive implications. Eisenhart and Zieberecke, 1992, document how decision quality depends on exploring diverse options before selecting. When AI assisted analysis generates convergent recommendations across ostensibly different approaches, organizations face the illusion of choice, apparent optionality that masks underlying uniformity. This creates strategic risks. Organizations may commit to approaches that competitors, using similar AI tools, simultaneously pursue. Organizational learning and adaptation. March 1991 distinguishes between exploitation, refining existing capabilities, and exploration, discovering new possibilities. AI homogenization skews this balance toward exploitation of established patterns, undermining exploration essential for long-term adaptation. Organizations using AI for environmental scanning, trend analysis, or opportunity identification may miss emergent patterns that fall outside dominant AI framings. Talent development and human capital. perhaps most concerningly for long-term organizational capability, reliance on homogeneous AI may atrophy employees' capacity for divergent thinking. Jeppesen and Lakhani, 2010, demonstrate that exposure to diverse problem-solving approaches enhances individual creativity. Conversely, repeated exposure to convergent AI outputs may train employees toward conventional thinking, reducing their ability to generate novel ideas independently. This creates organizational fragility. Capability becomes dependent on external systems rather than residing in human capital. Individual and team impacts. Beyond organizational level consequences, the artificial hive mind affects how employees experience and perform their work. Cognitive development and skill building. Employees, particularly early career workers, develop professional expertise partly through exposure to diverse approaches, styles, and framings. Mentorship, cross functional collaboration, and varied project experiences build cognitive repertoires. Ocasio, 1997. When AI becomes a primary source of examples, suggestions, and problem solving approaches, homogenization in AI outputs constrains this developmental process. A junior strategist learning through AI assistance encounters a narrower range of strategic frameworks than one exposed to multiple human mentors with distinct perspectives. Autonomy and agency. Experiencing work as meaningful partly depends on exercising genuine autonomy and seeing one's unique contributions valued. Hackman and Oldham, 1976. AI homogenization threatens this in subtle ways. When employee-generated ideas converge with AI suggestions, or with other employees' AI-assisted ideas, distinguishing genuine human contribution from algorithmic influence becomes difficult. This ambiguity may reduce the psychological rewards of creative work. Collaborative diversity and team dynamics. Effective teams leverage member diversity, different backgrounds, expertise, cognitive styles, to generate superior solutions. Page 2007. AI homogenization may mask this diversity. Team members who have consulted similar AI systems may unconsciously converge in their thinking, reducing the cognitive variety the team can access. This creates an insidious form of groupthink, Janney's, 1972, apparent independent convergence that actually reflects shared dependence on homogeneous AI inputs. Stress and decision confidence. Paradoxically, AI homogenization may simultaneously increase decision-making stress and false confidence. Employees face stress when ostensibly sophisticated AI tools provide similar recommendations across platforms. This apparent consensus may suggest the right answer exists, creating pressure to conform. Yet this consensus may reflect algorithmic convergence rather than genuine agreement across independent perspectives, leading to false confidence in potentially flawed approaches. Evidence-based organizational responses. Organizations need not passively accept AI homogenization. Multiple intervention points exist across leadership communication, work design, capability development, and governance structures. Strategic communication and expectation setting. Transparency about AI limitations. Leaders must communicate candidly about AI homogenization risks rather than treating AI as unambiguously beneficial productivity tools. This includes educating employees about intra and inter-model convergence, helping them recognize when apparent diversity in AI outputs masks underlying uniformity, and setting realistic expectations about AI's role in creative and strategic work. Effective approaches. Regular briefings on AI capabilities and limitations for teams integrating AI tools, using concrete examples from the organization's domain to illustrate homogenization risks. Decision process documentation that explicitly notes when AI consultation occurred and how recommendations were validated against independent human judgment. Red team exercises where designated employees deliberately surface AI limitations in specific work contexts, building organizational awareness of failure modes. Transparent metric development that distinguishes between AI-assisted productivity gains, speed, efficiency, and potential quality/diversity trade-offs. A global consulting firm instituted quarterly AI state of practice briefings where analytics teams demonstrated current AI capabilities and limitations using client engagement examples. These sessions explicitly covered homogenization risks, showing partners how different AI tools produced convergent strategic frameworks for similar problems. This transparency helped partners develop realistic expectations and more carefully structure AI integration into client work, reframing AI as augmentation, not substitution. Cognitive frames shape how employees engage with technology, Orlikowski and Gash, 1994. Framing AI as substituting for human creativity encourages passive acceptance of AI outputs. Reframing AI as augmentation that requires critical human judgment positions employees as active evaluators rather than passive consumers. Effective approaches: language protocols that consistently describe AI as draft generators, suggestion engines, or option expanders rather than solution providers or answer sources. Workflow redesign that structurally separates AI generation phases from human evaluation and synthesis phases, preventing premature commitment to AI outputs. Recognition systems that explicitly reward instances where employees identified AI limitations, generated alternatives AI missed, or synthesized across diverse inputs, including, but not limited to, AI suggestions. Competency models that include AI augmentation skills as distinct from general technical skills, encompassing critical evaluation, prompt engineering, and synthesis capabilities. A marketing agency revised its creative brief templates to include explicit sections for AI generated options, human alternatives, and synthesis rationale. Creative directors received training on facilitating discussions that positioned AI outputs as starting points requiring human judgment about brand fit, audience resonance, and creative distinctiveness. This structural change shifted team dynamics from accepting AI suggestions to actively evaluating and extending them. Work design and role restructuring. Deliberate diversity injection. Organizations can intentionally design workflows to inject diversity that counteracts AI homogenization. This requires moving beyond simply using different AI tools, which, as research shows, may produce convergent outputs, to structuring work processes that incorporate genuinely independent perspectives. Effective approaches: parallel generation protocols, where subteams develop ideas independently before AI consultation, preserving human originated diversity that AI use might otherwise suppress. Sequential diversity methods alternating between AI consultation for rapid option generation and structured human brainstorming using techniques explicitly designed to elicit divergent thinking, e.g., scamper, lateral thinking exercises. External perspective integration through deliberate consultation with domain experts, adjacent industries, or diverse stakeholder groups whose inputs haven't been homogenized by common AI exposure. Analogical reasoning exercises where teams systematically explore solutions from distant domains that AI systems, trained primarily on proximate patterns, might miss. A pharmaceutical company restructured its drug development ideation process to begin with human brainstorming using structured creativity techniques, followed by AI assisted literature review and mechanism exploration, then deliberate consultation with patients and clinicians, whose perspectives weren't represented in AI training, before synthesizing across these sources. This sequencing preserved human creativity while leveraging AI efficiency for specific subtasks. Role evolution and skill development. Job redesign should acknowledge how AI changes skill requirements while preserving roles for distinctly human capabilities. Rather than simply making existing roles more efficient with AI, organizations should reconfigure work to emphasize activities where human judgment, contextual understanding, and creative diversity matter most. Effective approaches: curator-creator role evolution, where content roles shift from primary generation to evaluation, synthesis, and quality assurance across diverse inputs, including AI-generated material. Prompt engineering and query design as formalized skills, with training in how to structure requests to AI systems that maximize useful diversity rather than defaulting to convergent outputs. Synthesis specialist positions responsible for integrating across AI-generated options, human expertise, and stakeholder input to generate approaches that transcend any single source. Diversity auditing roles tasked with monitoring whether organizational outputs, strategies, creative work, technical solutions Maintain sufficient differentiation from competitors despite common AI tool usage. A strategy consulting firm created synthesis lead roles on engagements, distinct from analysts and AI tool operators. Synthesis leads receive training in creative combination, analogical reasoning, and client specific contextualization. Their mandate: ensure final recommendations meaningfully integrated human expertise, client context, and AI generated analysis rather than defaulting to convergent AI suggestions. Compensation explicitly rewarded instances where synthesis leads identified and incorporated perspectives AI had missed. Governance and decision architecture. Multi-source validation requirements. Decision governance can mandate that significant choices incorporate genuinely independent perspectives beyond what single or similar AI sources provide. This requires procedural safeguards that prevent premature convergence around initially appealing AI-generated options. Effective approaches. Devils advocate protocols requiring designated team members to generate counterarguments and alternatives to AI recommended approaches, with explicit documentation of this contrarian analysis. Pre-commitment to alternatives where teams identify multiple plausible approaches before AI consultation, preventing AI outputs from anchoring subsequent thinking. Staged decision processes separating divergent generation phases, where AI may supplement human creativity, from convergent evaluation phases, where human judgment about strategic fit, organizational capability, and competitive differentiation dominates. Decision postmortems that track whether chosen approaches proved differentiated from competitors' choices, and whether common AI tool usage contributed to any problematic convergence. A technology company instituted a strategic options charter requiring product strategy decisions to document at least three genuinely different approaches, assessed by independent reviewers for true differentiation, before final selection. Teams could use AI to help generate or evaluate options, but governance prevented simply selecting the highest rated AI recommendation without demonstrating consideration of meaningfully different alternatives. AI tool portfolio management. Rather than standardizing on single AI platforms, organizations might deliberately maintain diverse AI tool portfolios, actively monitoring whether this diversity generates genuinely different outputs or merely creates the illusion of diversity through surface variation. Effective approaches. Comparative output analysis, periodically testing whether different AI tools in organizational use generate convergent or divergent responses to representative organizational queries. Provider diversity requirements for critical functions, mandating use of AI systems with different training data, architectures, and alignment approaches to minimize convergence risks. Internal capability development, investing in domain-specific AI systems, or fine-tuning that incorporates organizational knowledge and priorities underrepresented in commercial AI training. Open source AI integration alongside commercial platforms, providing access to models with different training corpora and development approaches, subject to appropriate governance for quality and safety. A financial services firm established an AI diversity assessment process, periodically testing organizational AI tools against standardized strategic, creative, and analytical prompts. When testing revealed convergent outputs, similar investment theses across platforms, identical risk framings, the firm deliberately introduced different AI systems or developed custom models incorporating proprietary research that commercial AIs lacked. Capability building and organizational learning. Critical AI literacy programs. Beyond basic AI skills training, organizations need systematic capability, building in critical evaluation of AI outputs, recognition of homogenization patterns, and techniques for generating genuinely novel ideas that AI systems haven't encountered in training. Effective approaches. Homogenization recognition training, helping employees identify when apparently diverse AI outputs actually reflect convergent thinking, using examples from organizational work. Prompt engineering for diversity teaching techniques for structuring AI queries that encourage broader exploration rather than defaulting to dominant patterns in training data. Creative confidence building, specifically addressing potential atrophy of employees' independent creative capacities through excessive AI reliance, using exercises that develop divergent thinking skills. Cross-industry learning exchanges exposing employees to approaches, frameworks, and practices from distant domains that organizational AI systems, trained primarily on proximate examples, might not surface. A media company developed a creative resilience program combining cognitive training in lateral thinking and analogical reasoning with practical exercises in identifying AI homogenization. Participants practiced generating ideas before AI consultation, comparing their ideas with AI outputs, and consciously developing hybrid approaches that integrated human creativity with AI efficiency. Program graduates reported sustained confidence in their ability to generate distinctive content, even as AI tools became more prevalent. Organizational memory and distinctive capability preservation. As AI becomes embedded in organizational processes, preserving and transmitting distinctive organizational knowledge, practices, and approaches, elements that differentiate the organization but may not appear in AI training data, becomes critical. Effective approaches. Proprietary knowledge documentation, capturing organizational approaches, client insights, and domain expertise in formats that inform future AI customization or fine tuning, rather than relying solely on generic commercial AI. Mentorship and apprenticeship preservation, maintaining human to human knowledge transfer mechanisms that communicate tacit knowledge, contextual judgment, and organizational culture that AI cannot capture. Distinctive practices identification, systematic analysis of what makes organizational approaches valuable and different from competitors, with deliberate strategies for preserving these differentiators as AI adoption accelerates. Historical case analysis examining instances where organizational distinctive capabilities generated competitive advantage, extracting lessons about maintaining differentiation in an AI augmented environment. An architecture firm developed an internal design philosophy codex, documenting the firm's distinctive approaches to sustainability, community engagement, and spatial innovation. This codex served both as training material for new architects and as foundation for customizing AI tools to reflect firm-specific priorities. The firm paired this with mentorship protocols, ensuring senior architects transmitted contextual judgment about when to leverage AI efficiency and when distinctive human creativity mattered most for client relationships and competitive positioning. Building long-term organizational resilience in an AI-augmented environment. While the preceding interventions address immediate AI homogenization risks, organizations must simultaneously develop long-term structural capabilities that preserve cognitive diversity, creative vitality, and strategic differentiation as AI becomes increasingly sophisticated. Distributed intelligence systems. Rather than centralizing AI decision-making or allowing unconstrained individual AI usage, organizations can develop distributed intelligence architectures that systematically combine human and AI capabilities while preserving diversity. This involves designing organizational structures where decision-making authority remains with humans for choices requiring strategic judgment, competitive differentiation, or creative distinctiveness, while AI handles well-defined optimization and efficiency tasks. Information flow protocols ensure AI-generated insights and analyses reach decision-makers through filters that preserve context, acknowledge limitations, and prevent premature convergence. Feedback mechanisms continuously update organizational understanding of where AI provides genuine value versus where it constrains thinking, allowing adaptive reconfiguration of human AI collaboration. Organizations implementing distributed intelligence recognize that optimal human AI collaboration varies by task, context, and objective. Strategic planning may benefit from AI assisted analysis, but require human synthesis. Content generation may involve AI drafting with human evaluation and customization. Customer interaction may alternate between AI efficiency for routine matters and human engagement for relationship critical moments. The key is designing systems that make these distinctions explicit and adaptive, rather than defaulting to patterns of AI use that evolved organically without strategic consideration of homogenization risks. Pluralistic value frameworks. Current AI systems optimize for consensus, generating outputs that average human raters find acceptable. This alignment approach inadvertently suppresses diversity, as models learn to avoid anything that might polarize evaluators, even if specific audiences would find it highly valuable. Organizations can develop pluralistic value frameworks that explicitly define when consistency and convergence provide value, brand compliance, regulatory adherence, quality standards, versus when diversity and differentiation matter, creative positioning, strategic innovation, customer personalization. Evaluate AI outputs against multiple value dimensions rather than single quality scores, assessing not just acceptability but distinctiveness, novelty, and fit with specific organizational objectives. Maintain diverse evaluation panels for assessing AI assisted work, ensuring evaluators represent the range of perspectives the organization seeks to serve rather than converging on consensus judgments. Reward boundary spanning ideas that may polarize evaluators, but offer distinctive value for specific segments, applications, or strategic objectives. A media company, for instance, might evaluate AI assisted content not just on general quality, but on distinctiveness from competitor content, alignment with brand voice, which may intentionally diverge from generic AI outputs, and resonance with specific audience segments. This multidimensional evaluation prevents defaulting to safe, homogeneous content that offends no one but excites few. Continuous adaptation and future proofing. AI capabilities evolve rapidly. Organizations need dynamic governance frameworks that adapt as AI systems become more sophisticated, training data expands, and homogenization risks evolve. This requires regular AI impact assessments, examining whether organizational AI usage patterns generate intended benefits without unintended consequences for creativity, differentiation, or employee development. Horizon scanning systems, monitoring AI research and development for emerging capabilities that might alter human AI collaboration dynamics or introduce new homogenization risks. Experimental protocols for testing new AI tools, techniques, or applications in controlled organizational contexts before broader deployment, specifically assessing diversity and differentiation impacts. Learning communities connecting practitioners across organizations to share insights about effective AI integration, homogenization mitigation, and maintenance of distinctive organizational capabilities. Organizations treating AI as evolving capability, requiring continuous adaptation, rather than static tool, to be deployed once position themselves to capture AI benefits, while mitigating risks that early adopters may not have anticipated. Conclusion. The artificial Hivemind phenomenon poses profound challenges for organizational leadership and work design. As AI systems become embedded in knowledge work, creative processes, and strategic decision making, their tendency toward homogenization threatens organizational capabilities that depend on diversity. Innovation, strategic differentiation, employee development, and adaptive capacity. Yet this challenge is addressable through intentional organizational design. Leaders who transparently communicate AI limitations, redesign work to preserve human creativity, establish governance preventing premature convergence, and develop capabilities for critical AI evaluation can harness AI efficiency while maintaining cognitive diversity. The path forward requires rejecting false dichotomies between AI adoption and human creativity. Organizations need not choose between productivity gains from AI and preservation of distinctive thinking. Instead, the imperative is designing systems that leverage AI for well defined tasks while preserving, indeed, protecting, spaces for human judgment, creative divergence, and strategic differentiation. This requires recognizing AI integration as organizational change management, not merely technology deployment. It demands attention to how AI reshapes roles, affects employee development, influences organizational culture, and alters competitive dynamics. Organizations that treat these as central leadership challenges, rather than technical implementation details, position themselves to build sustainable competitive advantage in an AI augmented future. As AI capabilities continue advancing, the organizations that thrive will be those that learn to orchestrate human and AI intelligence in ways that preserve and enhance what makes them distinctive. They will be the organizations that deliberately inject diversity into AI assisted workflows, maintain human capabilities that AI cannot replicate, and build governance, ensuring that efficiency gains from AI don't come at the cost of the creative vitality and strategic differentiation that ultimately drive organizational success.